set theory. Before we get into actual set theory, which is a lot of symbols and a lot of drawings, we need to just have a good understanding of vocabulary that we're going to use. The first vocab that we're going to talk about is if things are true or false, like statements. So you'll notice there's an example of two statements here, right? It says Edmonton is a city. That is a statement because it's a true fact. Like you can't agree with that, you can't disagree with that. It's a fact. The one below says Edmonton is the best city would be considered like a statement or an opinion. Right? Because to me, I might be like, yeah, Edmonton's the best city, but to Lexi might be like, no, Edmonton's not the best city. Right? This is something that can be argued over because it's opinion. This is fact. No arguing over it. We're going to be dealing with facts as facts. So anytime you're doing something, if you have to write a statement or talk about a statement, you want to use fact-based statements. And you can always label those things as either true or false. Down here we have 3 examples. So we'll look at them and we'll label them as being true statements or false statements. First one says the number 4 is a prime number. Prime is probably something a lot of people have forgotten. A prime number is a number, and like the best way to put it is it's a number that can't be divided by anything. That's honestly the best way to put it. It can only be divided by the number 1 in itself. I'm just going to say prime number is a number that can't be divided. Now, like, the math definition people of the world would probably kill me for saying that. It can't be divided by something, just only 2 things. 1 in itself. The best way to know it is a number that can't be divided by anything. So when you see a statement, like this one right here, the number 4 is a prime number, can you divide the number 4 by something? Yeah, by 2, right? So is this a true statement or a false statement? It's false. Perfect. The number 5 is an odd prime number. So odd is number 5 odd? Yes. Is number 5 prime? Yeah, it can't be divided by anything, right? That would be a true statement. The last statement. When you double an odd integer, you get an even integer. So double means to multiply something by 2. Right? So if you took an odd number, like the number 3, and you times it by 2, you get an even integer. You get 6, right? And does that always work? So if you can find one example where it doesn't work, then this is false. If you can't find an example, then this is true. This is true, right? So any odd number times 2 will always be even. But all it takes is one counterexample to make the whole statement false. Okay, the word not. So we're going to learn, I think, 3 words. I think we're going to do not, and then we're going to do and then we're going to do or, and what they mean when it comes to math statements. So the word not. We say that the word not, I use the definition of here. That's okay. The word not it negates something. So if something used to be true, when you add the word not, it should make that statement false. If something used to be false and you add the word not, then it should make that statement true. It reverses whatever the statement was. If it was a true statement, it's false. A false statement is true. So if you look here, they use the word not. The first statement was Edmonton is in the province of BC. That's false. That's not true. I'm pretty sure. 50-50. The second statement, they've included the word not. And it'll change that statement from a false statement to a true statement. So it says Edmonton is not in the province of BC. Now you have a true statement. It's the opposite effect. Okay? And we're going to use this in math. Tomorrow we'll start with all this stuff. But the idea is when you use the word not, it should be the complete opposite of what you had before. False things become true. True things become false. Down here, next page. Right here they have 3 examples of how they've tried to negate something or change it from a false statement to a true statement. The original statement was, all triangles are isosceles. That is a false statement. Okay? They want to add the word not to make that a true statement. There's 3 options here. Option A says all triangles are not isosceles. Is that true or false? That's false, right? That all triangles are not isosceles means there's no such thing as an isosceles triangle, but there is. So this is still false. Statement number 2 says not all triangles are isosceles. That is true. And the last one doesn't even use the word not. It just says all triangles are scaling and equilateral. That's also false. The statement that used the word not correctly is the one that changed it from a false statement to a true statement. So in this case, this statement correctly used the word not because it went from false to true. The opposite effect. Down below, you can do 2 of them, so you can write your own sentence below. But you want to use the sentence, add the word not to the sentence so that it's no longer true or it's no longer false. So for instance, it says it is 20 degrees outside. That's currently false. If I wanted to make that a true statement, I would say it is not 20 degrees outside. Turn a false statement into a true statement by adding the word not. Go ahead and do it for B. So to see if you either can add the word not or do whatever you need to do with the word not, but make it a true statement. It's currently a false statement. At least you could do double not, that'd be really good. So it says today is not Friday, so that would be a true statement. So if you wanted to reverse it into a false statement, how would you change it? Yeah, so how could you reverse this? And this one already has the word not in it. So instead of adding the word not, you could remove the word not and then say today is Friday. So it goes both ways, right? You could add the word not to something, or you could take away the word not from something, and it should reverse the true statement. It went from true, now it's false. Alright, not is usually pretty easy. Actually, all these are pretty usually, yeah, okay, I'm getting it. And then we added the symbols tomorrow. The word and. So the word and is like a conjecture or something like that. It's conjunction. Look at that. Pretty good for a math teacher. It's a conjunction. It means it takes 2 statements and it combines them into 1 statement. The word and can only create a true statement if both statements by themselves were true statements. Right? So if I have 2 statements, I want to write them as one by using the word and, then both of them had to be true to make the new statement true. There's some examples here, okay? So the first one says, blue is a color. That's 1 statement. And it's true. Blue definitely is a color. And ice is a solid. That's a 2nd statement. It is also true. When you use the word and for the entire thing to be considered true, then both statements have to be true. So this thing as a whole is true. But that's because both statements individually were true. We use the word, I believe it's inclusive. It's not on there. No, we use that with or. Okay, second one. It says blue is a color, so that's one statement. We look at that statement by itself. That is true. And ice is a gas. That is false. When you're using the word and, both statements have to be true for the whole thing to be true. In this case, we have one true and one false. That means the entire statement is false. When using the word and, everything about that statement has to be true. The last one. It says blue is a flavor, which that created like a heated argument last year about if blue is a flavor or not. Blue is not a flavor. It is not true. Even though it's like, someone's like, what's your favorite kind of Powerade? It's somebody in the room will say blue. They don't know the name of the flavor. They say it's blue.
They got a flavor called blue raspberry.
But that's blue raspberry is the flavor, right? You know, it's just blue. But then, like, what's your favorite kind of sucker or something, right? And people will be like, red. But that's not the flavor. Like, red's not a flavor. That's the color. Anyway. Blue is not a flavor. This is like the water is wet argument. Like, I've been way too involved in that. Like, I'm invested in that argument. But can you... Okay. On that. Okay, blue is not a flavor. So that is false. Yeah. And then you have the word and, right? And then you have ice is a liquid. Also a false statement. Ice solid. I should have picked less controversial things. I mean, ice, if it's left out in the heat, will turn into a liquid. You have a false statement and another false statement. For some reason, people sometimes get things all backwards and think two falses, like two wrongs make a right. Right? Two falses make a true statement overall. That's not how it works. This still is a false. Yeah, the double negatives, right? Two negatives makes a positive. No, two false statements connected by the word and, still a false statement. Right? The overarching is still false. The word and only creates a true statement if both things individually are true statements. I think we should have some examples of that. Beautiful. So for each of these, put true or false. So you're going to do them on your own. You're going to say, yes, that entire statement is true. No, this entire statement is false. One or the other. So if we're looking at these as entire statements, the first one says all prime numbers are even, and 5 is a prime number. You'll notice the word and is included, which means this can be broken up into two separate things. This is statement 1, this is statement 2. The one that I've highlighted in green says all prime numbers are even. The number 3 is a prime number. It can't be divided by anything. The number 3 is definitely an odd number. That means that this is a false statement. Not all prime numbers are even. If one of the statements is false, then I can just jump right to the end and say that the entire thing must be false. But just for fun, 5 is a prime number. That is true. 5 is a prime number. It can't be divided by anything. However, using the word and, you need both things to be true. It's not that way. So the overall answer is false for A. For B, if dogs are animals, that is definitely a true statement. And 7 is a prime number. Also a true statement. 7 cannot be divided by anything. This means that the entire statement is a true statement, because both things individually are true statements. The last one. 5 is not a prime number. 5 is a prime number, but they said 5 is not. That means this thing is false. The other one. 9 is a prime number. That is true. You have one false, one true with the word and in between. That means the entire thing is false. Any questions about those two? You all right? Okay, just for your own peace and sanity, write some sentences on your own. Write 2 statements using the word and that would be true, and 2 sentences with the word and that would be false. I'll write up examples as well. Really creative. So for a true statement to use the word and, you need 2 true statements. For a true statement to use the word and, you need 2 true statements. I did that in both of these. I did 3 is odd and 4 is even. Both things are true. Overall statement's true. Down here I said 7 is a prime number and Canada is a country. Both statements true. Overarching statement must be true then. The other one over here, these 2 things are false. So I said blue is a color, that is true, and 2 is odd. 2 is not an odd number. 1 false makes the entire thing false when you use the word and. This one down here says 3 is prime and 10 is odd. 10 is not an odd number, so the overarching statement is false because 1 was true and 1 was false. I just want to add something into that first slide where I talked about prime numbers. I just want to add the number 1 is not prime. Either is 0. The reason I'm including that, these definitions for prime numbers, is it's just a typical example for some reason that comes up in the math book. They like to talk about prime numbers. So it's good to know that prime numbers are numbers that you can't divide. 1 and 0 don't count. Okay, so the first prime number is the number 2, and then it goes up. Figured I should include that in case you forgot. So 1 and 0 are not prime numbers. Okay, and people are usually pretty good with or throws people off. The reason or throws people off is because you can use it in 2 ways. There's how we use it, right? Like in common day language, but then there's the way that math uses the word or. The way we use the word or sometimes is like if I'm at home, I'm like, you need to eat your supper or you go to your room, right? You're going to get one of those things, right? Like do this or that's going to happen. The way we use it in math is inclusive, meaning that we say this is true or this is true. Okay, so we could say something like the number 2 is even or the number 2 is off. Right? Like that's like one of these 2 things could be true. You don't need to worry about getting tricked on that stuff. They're not going to throw something at you like this happens or that happens. And they'll always be statement based. Okay? So you don't need to sweat about that kind of stuff. The actual words. Yeah, disjunction. Look at that. English teachers should be proud of me. So the word or is inclusive, meaning it's a disjunction, not a conjunction. That's the word and is conjunction. I'm doing really good at this vocab. Here, we have some things that explain when an overall disjunction is true. So when you have 2 statements linked with the word or, if the first statement is true, then the overall thing will be true. If just the second statement is true, the overall thing will still be true. And if both statements are true when you use the word or, then the overall thing is true as well. There's some examples here. The number 5 is even or it is odd. You have one statement here. 5 is even. That's false. Or 5 is odd. That's true. When using the word or, you only need one true statement to make the entire thing true. So that's one false statement, one true statement. This one, the number 4 is prime. The number 4 is not a prime number. So that is false. Or it is even. It only takes one true statement to make an or statement true. So that overarching thing is below that. The number 11 is prime. The number 11 is prime. It cannot be divided by anything. So the first statement is true. Or the number 11 is odd. That's also a true statement. Both statements are true, so the overarching thing is still true. We use the word inclusively. So that means it could be this one, or it could include both of them and still be a true statement. The last one is a false statement. So it goes, the number 6 is odd. That's false. Or it is prime. The number 6 is not a prime number. Two falses connected with an or is false. Make sense? Yeah. Or examples. So this one's a little tricky because people are like, what do you mean consider the number x? So it says consider the number x to be any natural number. Go natural numbers for a second. Natural numbers is something that might come up in your world. It might be in a test or it might be on a diploma or something. A natural number means it's a counting number. Like you could count it on your fingers if you had a lot of fingers. So 1, 2, 3, 4, 5, 6, 7, all the way up to infinity. Doesn't include the number 0. It doesn't include negatives, doesn't include decimals. So it's just counting. So it says, consider the number x to be any natural number less than or equal to 15. So that means x could be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, or 15. It could be any of those numbers. You don't know which one it is. It could be any of them. So that means when they give you statements about the number x, it has to be true for all these numbers. Right? So let's read the first sentence. It says x is odd or even. That's true, right? It's got to be odd, which would be one of these ones. And if it's not odd, then it's got to be even, which would be one of the other numbers. So this overarching statement would be a true statement. If one of them's not true, the other one would be true. So one of them will always be true. The number x is a multiple of 2 or 3 or 5. So there's 2 or statements in this, or 2 uses of the word or in here. That means only one of these things has to be true to make the whole thing true. Is there a number here that could be x that's not a multiple of 2, 3, or 5? The number 1. Could you multiply 2 by something to get 1? Using natural numbers, you couldn't, right? So when we say multiples, that means like 2, 4, 6, 8. Those are the multiples of 2. For the multiples of 3, it'd be 3, 6, 9, 12. For 5, it'd be 5, 10, 15. Is it possible that this could be false? Yeah, the number 1 wouldn't fit in any of these lists. So overall, that thing would be false. And C is the trickiest one of all of them. So X says, X is odd or prime. Is there a number in this list that's not odd and it's not prime? Yeah, number 4, right? The number 4, not odd, not prime. So that would create a false statement overall. For number 2, I want you to create 2 statements using the word or that are true, 2 statements using the word or that are false. And they can be about anything, right? So that you can be like, Canada's a country, or dogs don't have hair. Right? Whatever you want. But 2 that are true, 2 that are false. I'll put mine up here. They'll all be super creative. The first statement, 2 is prime, that's true. 2 is a prime number. It can't be divided by anything. Right? And then all dogs have fur is not true. But you have 1 true with the word or, the whole thing is true. Second statement says fish are humans, that's false. Fisher. Or Canada has 3 A's, right? The word Canada has 3 A's in it, which would be true. So that means the overarching thing must be true. Over here, you have dogs or cats, that's false. Fish can fly, that's false. I mean, some fish can fly. It's a video game. Yeah, flying fish, that's a thing. But overall, not all fish can fly, so that's a false statement. Next one, 2 is odd, that's false. 2 is an even number. And 10 is odd, that's false. 10 is also an even number. So that means this overarching statement would be false. So everything we did today was using the words and, or, and not. Tomorrow, we'll start using those words, but with math symbols. Okay? And that's how this all kind of links into what we're doing. Just an example of what this could look like. So, for instance, you're going to see things like this, which you don't even know right now. But if this says C is a part of not A. And you're going to need to know what that means when you're actually talking about it in okay? So that's how we're going to be doing things tomorrow. And then for the rest of the week, we'll be working on this kind of stuff. So 1.3 we'll do Friday. We won't do a quiz until Tuesday next week. I know, the quiz freaked everybody out on Friday. So I'll do the quiz next week. We'll do the first 4 lessons, we'll do a quiz, and then we'll start the second half of this week. In university,